Or we could be looking at a limit as it's going to infinity. So there's two different ways we're going to talk about it today. So like I said, we could be looking at a value, and we decide that the value is either going up forever or down forever. So then that's an infinite limit. Or like I said, we could be looking at the graph as it's going towards infinity or negative infinity, and kind of see what the graph's doing. That one kind of mirrors the in-behavior stuff we talked about at the beginning of last year. So if it seems familiar, that's kind of why. But like I said, today we're going to talk about both of those types of infinity. And usually when we're talking about those, it involves some sort of asymptote of the graph. So I just have a couple of bullet points here. So again, limits can be defined using the graph's behavior. And then what we really want to do for that is look at kind of what is happening as it's coming into the graph, or coming into that value from the left side and the right side. So we're going to do something called a left-hand limit and a right-hand limit. There's some notation we're going to talk about. And if they're approaching the same value, then we can say that, okay, that's what the limit is. Okay. Otherwise, we could have limits be negative infinity, positive infinity, or sometimes your graph kind of levels out as it's going towards the infinity. So it could be some sort of number. Okay. Alright, so some notation. So we're gonna actually, some questions are gonna ask you to define three different limits. Okay, a left limit, a right limit, and an overall limit. Okay, so when we're talking about as limits approaching from the left, the notation we still use our abbreviation for limit. We have x approaches. I'm going to give you some sort of a value. Okay, and if we're saying that we're looking at it from the left side, this mark is there for a reason. You see a little exponent of a negative, not a number, just a negative. That notation is saying that that is the left limit. Okay, so we're going to have to get used to writing some of that notation. Then I'll give you some sort of function, so it'll be some sort of equation, and then we'll figure out what the limit is. Okay, a lot of times it's going to be an infinity of some type. Because a lot of times we look at an asymptote, okay? So as the graph's coming in, it might be hitting an asymptote and shooting straight up. So if it's shooting straight up, your limit would be infinity. It might be coming in from the left to hit a value and then shoot straight down. So then it's negative infinity. That's probably the two most common things. Sometimes it comes in at straight, and so it's just a number. But most of the time, it's either shooting up, so positive infinity, or shooting down, negative infinity, okay? So again, if you see that little exponent of a negative, that means we're coming in from the left side of the graph. Okay? Now if we want to do right limits, notice there's a very subtle difference between the notations. Instead of having an exponent of a negative, it's an exponent of a plus sign. Okay?
Is there going to be an exponent with it?
No. It'll just be a number, and then we'll put a little plus sign next to it. Okay? So we are going to get used to a little bit of notation. So this is where we're looking at the graph as it's coming in from the right. And again, it could be shooting up, down, or level down. Okay? So again, we'll just get used to a little bit of notation. So with our first examples, we're going to do like three limits. We're going to say the left limit, the right limit, and then if the left and right limit are the same, we can use that to predict the overall limit. If the left and right limit are not the same, then the overall limit would not exist. Okay? So that's some little notation that we'll get to as we look at this. Okay? Any questions on the notation? No? Okay.
Where's the graph?
So you'll have to look at the graph. Do not have to snip the graph. I have it snipped on the paper so that we can do our examples easier, so I don't have to go switching back and forth between left and right, or between Desmos and my Active Inspire. Okay, so I have snipped them on the examples for you, but you don't have to do it for your homework. Again, you just have to look at the graph and tell me stuff about it. Okay. Here we go. We're going to use the graph to find the left limit, the right limit of the function, and then use that to try to estimate the overall limit. Okay? And I have it set up in AB format, and I will want you to use the notation. So in this first example, I helped us out with the notation because I have it pre-typed. Okay? So this will be for part A. This will be for part B. Okay? after this example, we're going to work on writing it ourselves, okay? And then eventually, we're also going to do part C, where we just do the overall limit. And so when we do the overall limit, no little plus or minus. Okay. I know it's notation heavy, but I do want you to write all that out, okay? So like I said, I helped you with the left and right limits for the first one. So with the left limit, we look at the value. So we know we're looking at 0, and we're looking at this graph. So 0 is right here. So we're going from the left-hand side, coming into that value. What's the graph going to do as it gets to 0?
Go down.
Go down. Okay, so if it's going down forever, how do we say that mathematically? Negative infinity. So our left limit is going to negative infinity.
I love that.
So now we're going to switch things. Now we're going to come in from the right-hand side, okay? So we're following it here as it's hitting it on the right of it. And then what does it do as it hits 0? Goes up. So how do we say that mathematically? Positive infinity.
This is making me happy.
Okay. So as we went from the left into it, it was negative infinity. As we went to the right into it, it's shooting up, so it's positive infinity. So are those two things the same infinities?
No.
So that means the overall limit does not exist.
If they're not the same, then they just
Yeah.
don't exist.
If the left and right have the same limit, then the overall limit will be that limit. Okay. If they do not have the same limit, then the overall limit does not exist.
So the next one's gonna be positive infinity.
Questions about the first example?
Maybe.
Let's look at the next one.
Don't think so. It's gonna get tricky all of a sudden. Well, not really. Just only a little bit less.
The trickiest thing is probably just getting used to writing the notation. Okay, great. Alright, so I'm giving you a value. It's not always 0. Okay, it happens to be 0 again. So left hand limit, what's the little notation I'm going to put next to 0 to say it's left? Little negative exponent. Yep. Then write my function, which is e not squared 4. Leave a little space. You can do it as you go along, but I'm just going to write the notation for the first example. So we have limit x approaches 0. Again, it's not always 0, but I will give you a value and I will give you a function. So if I'm going to say this is the right function, what do I put with my little 0? A plus sign. Okay. And then I'm going to do the overall limit.
Wait. Why don't you have anything to beat?
It's there.
I thought I was already doing this round.
Alright. So now we're going to come in from that value at 0. So what's happening is it's coming into 0.
Going up.
Going up. So it's positive infinity. Okay? Now switch sides. Coming in from the right. Positive.
So overall is
Okay. So are those the same? Yep. So then my overall limit is the same.
Wait,
So if they're
question.
both going to positive infinity, then the overall limit we can say is positive infinity. If they're both going to negative infinity, we can say the overall limit is negative infinity.
Does the numbers mean anything?
Yeah, it's what value we're looking at.
You have to graph it yourself.
You don't have to do the graph. So you'll type in the 1 over x4 like I did, and then this tells you what value we're looking at. So we're looking at 0. Sometimes I might look at a different value. Like the next one we're going to look at 4 instead. Alright, so let's go do this as we go along. So we're going to do the left limit. So again, I know it's the left limit because I put that little negative there. onto the 0. So like I said, it's not always around 0. It just depends on what value I give you. And usually it's an asymptote. Okay, so if you see, that's where the graph breaks up. And so we're looking at this one. As it's coming in from the left side of 4. What does it do? Drop. So what's this limit? Negative infinity. So now we're going to do part B. We're going to do the limit for the right-hand side. So now we're coming in from the right-hand side. What does it do as it hits 4? Goes up. So what's my limit for the right? Positive infinity.
I think I can make this not exist.
And so then my overall limit, since those are not the same, does not exist.
Does anyone else have the issue where you draw your infinities as 8s?
Yes.
Mine just look really odd. My right side is bigger than my left.
I have to do a lot.
I still can't draw, you know those little squiggle bracket things?
I can't do those either.
I can't do that still. Like this? Yeah, I can't do that. It just looks like a weird face. Yeah, I can't do that.
I've done that somewhere else. Okay. Questions on left, right, overall limits. Yep. So that's one thing I'll have to do. And then like I said, then we're also going to be looking at limits as they're going to infinity. Okay? So the little number, instead of having a number here, like 4 or a 0, you're going to be looking as it's going either to positive infinity or negative infinity. That's what this next is.
We have to rewrite this one too.
No. So this will be written in limit form already. You just have to make it easy. Alright, so basically what we have to do, we either have to look at the left, what it's doing as it's going left, okay? So as it's going left, we're looking at in negative infinity. And then as it's going right, that's when we're looking at positive infinity. So that's how you can tell whether or not you look left or right. And then you basically need to say what the graph is doing. Like, so we have 3 options. It could be going up forever, down forever, or it might level out. Okay? So this one, and in your calculator, you'll just type this in. You don't have to type the limit notation, but this will be given to you, and then it'll tell you which infinity we're looking at. So I've typed this in and graphed it. So there's a lot of stuff going on here. What we're looking at is it's going to positive infinity. So we're looking as the graph's going to the right. So we look as if we follow this graph out right, is it going up forever?
No.
Down forever? No. Or is it leveled out? Okay. It is leveled out.
I bet it
So
goes
then we'll
down
say, because see how it's kind of leveling here?
Yeah, but like,
It won't ever cross that line.
Because there's an asymptote here.
but it still goes,
Yeah, it'll get closer and closer for the number of across the line.
yes, infinity.
So, what value
One.
is it leveled out? So we're going to say that this limit,
Wow.
let's just go that one. Okay, last one. Now we're looking towards negative infinities. Is that left or right? Left. Okay. So as we follow our graph out to the left,
It levels out.
it levels out at 2.
That's all? If focus on it gonna be different though and actually aren't the right problem. Because they always get rid of those.
I'll look at it. Alright, so I'm gonna look at the directions and make sure they're good to go. I tried to follow them.
Wait, why was this one negative 2?
Well, it wasn't too.
What did I just miss?
It levels at 2.
Oh, okay. I was like, it's not negative that way.
No, it's 2. Alright, so 1 through 4. That if you look in the directions, that's how it's A, B, C. Okay, so you're gonna do left, right, overall, and again, do it the same way I formatted my examples. So that's what 1 through 4 is. 9 through 13, that is where you're looking at a certain limit, okay? So a certain infinity. Again, if it's positive infinity, look to the right. Negative infinity, look to left. So that's what 9 through 13 is. And then does anyone have one? Oh wait, I don't like the directions for 23 to 28. Okay? So what I want you to do for that,
X them off.
do the ABC part. So do left, right, overall. Overall. Okay. You're gonna ignore the directions for that. And just do if there is 2 of them that have an A and a B, just do part A.
Is that what to do with that?
And then 9 through 13.
Okay, any other questions? Concerns?
That's a lot.